gonna make it on time. By the time I grab my books and I give myself a look, I'm at the corner just in time to see the bus fly by. It's alright, cause I'm safe at the fail. If the teacher pops a test, I know I'm in a mess, and my dog ate all my homework last night.
What's up, YouTubers? It's Mr. Gossam, here to teach you how to multiply and divide exponents, and then the other two teachers are going to teach you the rest of the page that we went over. So, multiplying exponents. So all you're doing when you multiply exponents, when you see anything like this, all you have to do is add the exponents, okay? So if I have a squared, that's like a times a. And if I have a to the fourth, that's like a times a times a times a. And these are being multiplied. So you are just adding how many times they're being multiplied together. So that's why we add the exponents. So you get a to the sixth. So that's all you have to do. So looking over here, the only thing that might throw us for a loop is we have 5 and we don't know what power it's to because there's nothing there. So if you don't see anything, it's always to the first power. So now all we have to do is add the exponents. So you get 2 plus 1, which would be 5 cubed. And I'm telling my kids to leave this, so it's up to the other teachers. I'm telling them to leave the 5 cubed. But if you want to, you can put 5 cubed in the calculator. 5 times 5 is 25. 25 times 5 is 125. So it depends on what your teacher wants you to leave it, but either one of these would be correct. Okay. So then, now we move into dividing exponents. If you add the exponents when you multiply, you're going to subtract the exponents when you divide. So all it is the top minus the bottom. So it's 8 minus 3. So you're going to have D, 8 minus 3 is 5. So 8 minus 3 is 5, D to the 5th. That'd be your answer. It's just that simple. So let's go ahead and move over to this side. Exact same thing, top minus the bottom. Now this negative symbol might mess you up because you're thinking 4 minus 1. But you were taking 4 and you're going to subtract then the bottom number, so that'd be negative 1. So 4 minus negative 1, if you're doing that, minus a negative or subtracting a negative is adding, so it's e to the 4 plus 1, which is just e to the 5th. And that is how you multiply and divide exponents. Now you know more.
I'm Mr. Hart, and I'm going to help you all with whenever you have an exponent already with a variable or a regular number, an integer, and you're raising it to another power, and also what we do whenever our final answer has negative exponents in it. So first on this one we have u squared, or u to the second power, and then we're taking that and we're raising it to the third power. So this is kind of similar to the distributive property, and really what we're doing, we're just taking this u squared here and we are going to have it 3 times. And just like what Mr. Goslin talked to you about, whenever we have a multiplication problem, all you do is just add the exponents. So this would be 2 plus 2 plus 2, which would be 6. Now that's kind of the long way, and if we want to cheat a little bit and do it a little bit quicker, all you have to do is just do 2 times 3 in your exponent and just keep that as u to the 6. So I would tell my students to do it like this and just multiply 2 times 3, but this is why it works. That's why we're allowed to just do that. Number 18, we're doing the exact same thing. The only difference is that our base is an actual number here. So I'm going to keep the 2 as my base, and then I'm going to multiply my exponents. 2 times 4, so my answer is 2 to the 8th. Now sometimes you might need to leave it like that, but if it's in a multiple choice form, if you're taking a test, or if you just want to keep it going further, you can put in the calculator 2 to the 8th power, and you get 256 as a final answer. So again, it just kind of depends on whether you want to keep going or if your teacher, whoever, asks you to go ahead and evaluate that. Now, with negative exponents, you cannot keep a negative exponent as your final answer. So whenever you're working with the exponents and maybe it's the problem or maybe you're in the midst of it and there's negatives, you don't really have to worry about getting rid of them then. But whenever you're done and your problem is complete, if you have a negative exponent, we want to get rid of it. So here we have x and it's raised to the negative third power. So what we're going to do, we are going to just change that negative 3 into a positive 3. Now, we can't just keep it like that. So what we're going to do is we're going to turn it into a fraction and we're going to move the x to the third to the denominator of the fraction to the bottom. And since there's nothing to put in the numerator on the top, we'll put a 1 there as our placeholder. So anytime you have just a variable or a regular number raised to a negative exponent, all you want to do, put it on the bottom of the fraction, put a 1 on it. Now, if you have something else to put up there, then we will, but this is a simple problem or a simple answer, so there's nothing to put there, so we just put the 1. Now, if it's already on the bottom of a fraction, but it's negative, then we're just going to do the opposite. So we're going to put 5 to the 4th on top of the fraction, but anytime you divide anything by 1, you're really left with itself. So we're not going to put that over 1 because it doesn't mean anything. It doesn't help us at all. And again, if you want to leave your answer like that, you can. But if you want to go ahead and take it all the way, 5 to the 4th power is 625. And now you know more.
Hey guys, it's Miss Garner. I'm going to cover the last section, which is having an exponent of 0. And then we're going to take it up a little notch and do a couple challenge problems. So for an exponent of 0, just a reminder, your exponent, that's your small number up in the top right corner there. Anytime you have an exponent of 0, the answer is always 1. So x to the 0 equals 1. The most common mistake that we see here is that you keep the exponent and you keep it as x to the 1. So you recognize that the answer is 1, but you keep it as an exponent. Remember, that's the same thing as just having an x, which we don't want here. So anytime there's an exponent of 0, the answer is just 1. So your exponent and base, they both completely go away. So 18 to the 0 is also equal to 1. Now for our challenge problems, you're going to do the exact same techniques that Mr. Gossam and Mr. Hart just showed you. You're just going to do it one variable at a time. So for our first problem, we notice that we have a 6 and we have a 2 in our numerator and denominator. These don't have exponents. So these, our exponent rules don't apply to them because they aren't exponents. So you're just going to do a normal division problem. 6 divided by 2 equals 3. We're now going to look at our x variable. So I see I have x to the 8th power over x to the 5th power. It's a division problem, so I'm going to have to subtract. So I'll have x to the 8 minus 5, which is 3, so x to the 3rd power. And now I'm going to look at my last variable, which is y. I've got y to the negative 2 over y. Remember, when there's no exponent, we're going to assume there's a 1 there. So we have y to the negative 2 over y to the 1st power. If we subtract those, we get negative 2 minus 1, which gives us y to the negative 3rd power. Since we have a negative exponent, we know it's got to go to the bottom of our fraction. So we're going to put it in the denominator underneath the terms we've already put there. So on the bottom, we'll have y to the 3rd power. Since it's in the bottom, it is now turned positive. So our final answer will be 3x cubed over y cubed. For our second problem, I noticed that each variable has an exponent, and then we have an extra exponent at the end. Anytime you see these parentheses and an extra exponent, you know it's got to be a power to a power problem. So our rule says to multiply our exponents. So if we do this one variable at a time, we'll have x to the 3rd power raised again to the 2nd power. So that gives us x to the 3 times 2, which is x to the 6. We have y to the 5th power raised again to the 2nd power. So y to the 5 times 2, which is y to the 10th. And then z to the 4th power raised again to the 2nd power. So we get z to the 4 times 2, which is 8. All three of these variables are different letters. We know they're different variables. They can't be combined. So our final answer is x to the 6th power, y to the 10th power, and z to the 8th power. And now you know more.